Okay, I'm done with the objects for condenser loop. I'll show you very fast what all I did. First, I made the demand side of condenser loop. I started with the demand inlet branch. Then this would be baby chiller and the big chiller. Then demand bypass and then demand outlet. Um, then on the supply side, um, we'll start with the pump. This is a inlet branch. Then there would be two parallel bypass and cooling tower. The cooling tower and then the bypass. And in the end, we'll make a condenser supply outlet branch. Then I listed all the branches. This would be demand side branches, inlet, then three parallel branches, then outlet branch, and then would be condenser supply side, inlet, tower, bypass, and outlet. After that, I made splitters for these both, and then mixers for these both, and connectors. Then I individually made pipe adiabatic and pumps. So there would be one, two, three, four, and five. There would be five in condenser loop, five pipes. Then there would be one pump for condenser pump. Uh, yeah, this is the object I wanted you to see. Cooling tower single speed. There are many types of cooling tower. We'll use the very first one. This all is the most like single speed would have the very least power, then the two speed, and these all you can see in the IO reference. Um, we'll try to keep everything auto size. There are two three which we can keep default as this zero point 0.1 and free convention U factor times area value sizing factor. This also can be kept zero point 0.1. This is also by default value. Okay, after making these branches, we have to make we have to write this in the plant loop. So we'll make another object, a new object in plant loop, condenser loop. Uh, Here the this set point would be the outlet of the supply side. This outlet node of the supply outlet pipe, and here I've made all the branches. I've inputted all the branches here. I'll show you the tower operation because that is more important. So we'll start with the list. There would be just one list. All we'll name it as all towers, and there would be big tower in that. Then we'll come to cooling load. This would run all around the year. So this would be from 0 to 90,000, and then would be the operation scheme. This is on because it will be running at the whole time. In this on schedule, there's just one value, one always. So it will be running all day round. Then we have to make two set point managers. Sorry, one set point. This is a followed outdoor temperature. This set point manager provides a temperature offset to the reference node, and if this value is 0 and the limits are met, then the resulting set point will be exactly the same as the outdoor wet bulb temperature. The sign convention is that a positive value here will increase the resulting set point to higher than outdoor air wet bulb temperature. So the set point node would be the outlet of the supply side. We'll put it here. Okay, here we are done with the all plant loops. We are done with chill water loops, condenser loops. After this, we'll start the air loops.